Today, the whole point of doing the data-driven exercise is to try to empower content creators, and try to remove the programmers as much as possible from the bottleneck that they often are. So we're going to see exactly how it works. So I'm going to start by doing like a setup from scratch. We're going to clone this engine from GitHub. It should take only a few seconds. There we go. And then we need to run the setup utility. It's a one-time operation that's going to gather dependencies, set up environment, create project files. You won't have to run that ever again, even if you pull. It's just a one-time thing. So let's now actually build the engine with Visual Studio. There we go. Again, don't worry, it only takes a few seconds to build it from scratch. We're going to build it for debug. Should take like 5-7 seconds, something like this. Building the profile version, which is optimized code with the internal profiler still available. And the last configuration that we're building is a release that we're going to use to ship our game. So we're going to make a small asteroids-like game. We're going to publish it for the web at the end of the session. So we also need to build for the web. We're going to do that with mscripton, with the config, release, web. Okay, while this compile takes about 20 seconds, Orcs is written entirely C. It's an open source game engine on which I've been working for almost 25 years now. And it follows like principle like ECS, except that 25 years ago ECS didn't exist, so it doesn't have exactly the same term. Like in Orcs parlance, entity are called objects, components are called structures. They are very similar. They are not 100% the same, but same idea. And then there's the data-driven aspect of it that we're going to see very soon. So we're going to create our project. For this, we're going to use a little utility called init. Init is just using a template to create a project, and you can select the kind of extension you want to add to it. By default, there will be the bundle extension, which is used to automatically gather, encrypt, and package resources, and the scroll extension, which is a C++ layer to allow for binding the C++ classes that we're going to create to the data. And we're also going to use the mod extension to play Amiga mod files. So we're going to create our little game, and we're going to add the mod extension. Done. And because I'm a Sublime Text user, Sublime Text user, I'm going to use Sublime Text. I'm just going to use Visual Studio to build it. There we go. Let's build the debug version. Command Visual, you can do it. There we go. So by default, the template has like a music playing. As you can see, there's a spinning logo with some color effect and a text. There isn't much to it, but let's see exactly what we have. So here, if we look at the code, there's a single file here, and I'm going to zoom because it's probably not very legible. Let's see. Okay. It is readable here. I assume so. There is a single call in the main function to run our game. The bind object is going to be interesting. That's where we're going to bind our data to our C++ classes. And here in the init function, we see that we push a section in the config. So the config is the data part of Orcs. It's mostly a repository of live data, and it's organized as key value pairs in sections. So by default, we're pushing the main section. That's what the template does. We don't have to do it if we don't want to. We're also going to create a bunch of viewport defined in config, and then we're going to create a single object, which is called scene here. We have a camera update we're not going to use. In Asteroid, the camera is not moving, so I'm going to get rid of this. And finally, we have an object function that's just monitor for the quit input and to leave the game. So that's all we have here. We also have a stub for a base object, and this one, as you can see, is really completely empty. You don't have to use it if you don't want to. It just shows you how to do it. So I mentioned the data part, which is key value pairs. One way to feed it is from config files, which look like INI files, but there's a bit more to the syntax. We can easily build like an editor on top of it, or we can use the live API. As I say, the data, when it's in memory, it can be easily modified. We can add keys, remove keys, change the parenting, do a lot of things. It's very prone to doing things like procedural generation, for example. So the first thing I'm going to add to this is going to add another class for the ship, for the controlling. And because I'm very lazy, I'm just going to save a copy of the object. I'm going to call it ship. And I'm going to rename it. Same for the header, ship. And we're going to do a bit of renaming. I like having my guard uppercase. And here we're going to extend the object class. Lastly, we're going to register our object, our ship, sorry. Include ship.h. And in the bind objects here, we're going to bind the newly created ship. And that's it for now. If we were to look at the config we had so far, because we had, remember, like a music, a spinning logo, and things like this, this is all the properties we have at the moment. We see that we had a scene object that we created, and we have a bunch of children, like the logo, the sound, the music, and things like this. In Arcs, everything revolves around objects, so you don't have a concept of a world or a scene or a level or a prefab. Everything is an object. Object can come with attached components or with children as well. And in this case here, we're going to get rid of all the children. We're not going to use them. They were made for the template. We're going to change a couple of settings just to make it more friendly for streams. Like we're going to go in window mode and we're going to say inherit. The @ sign is for inheriting. We're going to inherit from the frustum width of the camera, and the screen height is going to inherit from the main camera frustum height. And we need to regenerate the solution. We're going to do that with premake, because we added the ship class. Now, if we run it, we should have like a black window. We have access to a console. The console comes with a bunch of pre-made commands. There's about 300 of them. We can add our own commands if we want to, and there's about 100 to manipulate objects as well. This is probably a bit too small for you to be able to read comfortably. So one of the first things I'm going to do here is going to add the render section, and inside it, I'm going to add console font scale 3. And as soon as I save it on this, you can see that Arcs picked it up. There's hot reload support for any resources, and we're going to leverage this very heavily during the development this morning. So hopefully now this is readable. We need to start adding, well, game content. So we could put everything in one file, but it's going to become very messy very quickly. So instead of this, I'm going to split it in multiple files. And here you can also like do the split the way you want. I'm going to need like a ships.ini file. I'm going to need one for shaders. I'm going to have one for audio and one for UI. Okay, so we're going to start with the main.ini, in which I'm going to move like my scene, my camera, and my viewport. There we go. From the camera, I can remove everything that was for camera check. I'm not going to use this. And now we can start working with this. So first thing first, we need to spawn some asteroids. I'm going to create our asteroids.ini, and we're going to define asteroids. So you don't have to know all the property by heart. There are some cheat sheets. They are called templates. And in these templates, at the top, you have the explanation of the syntax. It's ini++, if you will, because we support things like inheriting at the section level, at the property level. We support things like random values, lists. We support things like commands and lazy commands and other things, and everything is explained at the top. And then this is a list of properties recognized by the engine out of the box. So for example, if I'm going to create an object, those are all the properties I can use out of the box. We're going to add our own properties as well. This is just what comes with the engine. I should not need them because I'm going to use like very common properties, but this is available for everyone to develop. So I'm going to say I need a spawner, and I want to define the spawner in the same section. So I'm going to use the @ sign for this. Again, I'm going to go very quick. I'm not going to explain everything. Feel free to ask any question at the end. I'm going to say I need to spawn something called an asteroid. I'm going to say I'm going to spawn them 10 at a time, every 5 seconds, and I never want more than, oops, I never want more than 10 at a time. I want to skip the first delay. And I want to make sure that when we delete the spawner, all the children are also deleted. Then I'm going to say, I want an asteroid that inherits from the object, so that the object C++ class is going to be instantiated with it. This is going to have a graphic, and it's going to use a texture. So we need some data. We're going to go see what we have here. I'm going to get rid of all the data that comes with the template. We're not going to use this. And instead, I've selected offline some Creative Commons 0 data that I'm going to use today. If we go to the texture, we see that we have some for asteroids. We're going to start with this little guy here. So asteroids there. And if I were to start the game again, you can see we have some asteroids here. So that's where we are going to do live edits. We're going to, there's 10 asteroids, but they are on top of each other, right? So we're going to give them like a random rotation. The tilde is for random, so between 0 and 360. And as soon as I save it, you can see that it's been reloaded. We're going to give them some angular velocity as well, between negative 90 degrees and plus 90 degrees. And we're going to scatter them like in a box from minus 100 to 100. There. And every time I save it, you can see that we get a different configuration. So we are out-reloading the config, but it works for any kind of resources. So if I were to open this with paint.net, for example, and if I were to try my best programmer art to make it a bit more pretty, as soon as I save it on this, you can see that it's being picked up, and that works for any kind of resources. Okay. So we need to make it a bit more pretty. We're going to go for like a fully saturated neon retro look. So I'm going to give it a color. I'm going to say anything between red and lime, and we can see that they are not fully saturated because the color property is in RGB space, so we want it in HSV instead. And now we can see we only have like fully saturated random colors. We have a few textures, so might as well use them all. Let's copy their name. And by the power of multi-edit, there we go. Oops. Bit too far. We're going to create a list and I'm going to remove the duplicate element. And now we can see as soon as it's saved, we get random texture from this list. We are going to give them a speed. And here I know this should have been called velocity. Unfortunately, when I started that over 20 years ago, my English was even worse than what it is today, if you can believe it. And in French, the word vitesse is used for both speed and velocity, and I chose the wrong one. Oh, there we go. We have asteroids that are being scattered. We are going to give them different size, and for this, I'm actually going to create different kind of asteroids. So a small asteroid inheriting from asteroid. Going to say the scale is going to be between 1 and 1.2, and we're going to do the same with like a big asteroid. The reason I'm separating it is later I'm going to give them different score values. So this one like around 3. There we go. Okay, and we need to spawn those guys instead of the asteroid. So small and big asteroid. And now we have our drifting asteroids. We need to be able to wrap around. So to do this, we're going to need to know the size of the arena. So we're going to create a new property called arena size in the main. And I'm going to inherit it from the size of the camera, except we don't have a size in the camera. So here I could say it's 1920 by 1080, but I want it to be dynamic. And for this, I can use a lazy command. So basically, we're going to run a command, and the return value of that command is going to be the value of the property every time we query it. We can chain commands by using a stack. So a command can push their result on the stack, and we can pop it as arguments for next command. And that's what we're going to do here. We're going to push retrieving the frustum height of the camera. Then we're going to push retrieving the frustum width of the camera. And finally, we're going to return a vector by popping these two values. If it didn't mess up, we should be able to retrieve main arena size, and you see it's 1920 1080. If I were to change this, you see that it's live modified, and that's what we need at the moment. Let's add the logic for it. We're going to go in our base object class, we're going to need 2 vectors. We're going to need one for the arena side that we just created and one for the position. We're going to retrieve the arena size. We're going to put it in arena. And then we're going to retrieve the position of our object. We're going to modify it, and then we're going to set it back. So here it's going to be very simple. We're just going to check if the X is past half the arena side on X. I swear I type better usually. And then here we're just going to remove the side of the arena. Okay. And so that's exiting on the right. We want to exit on the left as well. So if we are less than half the size, we're going to add it back, and we need to do it vertically as well. So here on Y, and if I didn't make any mistake, we should have wrapping asteroids. Let's see if that works. That works, except they are popping. It's not very pretty. So to do this, we're going to change our render pipeline. We're going to add a bunch of cameras at the edge of the current cameras, and we're going to render them all on top of each other. So here we're going to need like a top viewport, a bottom viewport, a left viewport, and a right viewport. And we're going to define those guys. Each viewport is going to have a camera. Oh my goodness. Camera. There we go. And this one is going to be named in a similar fashion to the viewport, and we're going to define them here. So camera, inheriting from main camera. They're going to use all the properties from the main camera. We're just going to change the position. We're going to say get our size and multiply our size by an offset. And this offset is going to be front. For the top, well, it's going to be above. Bottom is going to be below, on the left here, and on the right here. And if I didn't make any mistake by just doing this, we should have smooth transition, excellent, at the edge. Okay, we need some gameplay. We need some ships. At least we need a ship. So we're going to create the INI, and we're going to say we need a ship. Before I forget, I'm going to say the scene is also will also contain a ship. And the ship, well, it needs a graphic. It needs a texture. Let's go see a texture for the ship. Yeah, let's take this little pointy guy here. Shapes. We're going to give it a color, purple. We're going to say, and we can use numerical values for the color, just that it also recognizes the HTML colors, which is pretty handy in this kind of exercise. We are going to say that our ship, the orientation is vertical in the texture, but I want it horizontal. So I'm going to change the orientation. And what else? We also want to spawn away from the asteroid. So I'm going to spawn it on the left. And here we have our ship. We need to interact with it, right? So what we're going to do, well, actually, before I do this, I want to be able to restart the simulation without having to quit and restart like I've been doing right now. So let's do this. We could do this in code. We can do everything in code, actually, but it's a very simple manipulation. So I'm going to just bind some input to the scene. So as I said, everything revolves around objects. The way we interact with objects is with virtual input. So we can bind those input to like physical peripherals, but we can also trigger them like in code or in config. And that's what I'm going to do for the scene. We're going to define like key F1 for an input we're going to call reset. And we're going to handle it here using a trigger. And that trigger, when it receives the input reset, is only going to delete itself. The caret means this for commands. And here, when I say when we get deleted, we're simply going to create a new scene. So by doing this, by pressing F1, I can restart the simulation instantly, and that's going to be very handy. Okay, we need to interact with our ship. Oops, that's the wrong one. There we go. So we need some input. We're going to say we need an input per instance of the ship, and we're going to give it like default values. Those can be rebound at runtime. They can be serialized, saved, and loaded, but we need default values. Here I'm going to say the key A is going to be rotate counterclockwise. It is going to be rotate clockwise. We also probably need something like W for later. We're going to thrust, and S is going to be for shoot. We're also going to expose some designer variables so that they can tweak the behavior. So we're going to say we have a turn speed. We're going to put it at 1000 degrees per second. An acceleration. Oh my God. Okay. And yeah, now we need to write the logic. So let's do it in Visual Studio this time. We have our ship here. Hopefully it's readable. We're in C++, so we need to call the parent update so we can have the wraparound. We're going to push our config section so that we can retrieve the variable we just created, the turn speed and the acceleration. And now we're going to handle the rotation. To do this, we're just going to set the angular velocity of our object. We're going to retrieve the variable we created. So it was called turn speed. And we're going to multiply it by getting the value for our input called rotate clockwise. And we're going to subtract getting the value of rotate counterclockwise. There we go. And those are in degrees, but the engine expects radians, so we're just going to convert them into degree to radian. Okay. If I didn't mess up, we should be able to turn, except we're doing it much too quickly. So let's try turn speed 10. This time it's too slow. Let's try 200. 200 is pretty nice. Right now we are doing it with digital input, but let's say we also want to do it with a gamepad. So let's say that the negative left axis is going to be rotate counterclockwise, and the positive left axis is going to be rotate clockwise. We're going also to add like the left trigger as thrust, and the right trigger is going to be shoot. And if I didn't mess up, I need to plug my controller, turn it on. And there we go. And because this is an analog, I can actually turn very slowly or fast, depending on how much I push on the axis. I don't have to have like different code paths. Everything is handled just with a single line we put. We need to be able to thrust. So let's change the behavior here. We're going to say thrust now. For thrust, we're going to need a vector, and it's going to be speed. We're going to retrieve the current speed, and we're going to retrieve it relative to our orientation. Once we're done modifying it, we're going also to set it relative to our orientation. And in between, we're going to say speed on X. We're going to add the value from our acceleration that we defined in data, and we're going to multiply it by the value of our input that we call thrust. And because we want to stay frame rate independent, we also need to multiply all this by the dt. And not only that will make sure that we are frame rate independent, but we will be able to do time stretching as well. Maybe we will demonstrate this. So I can thrust, though probably a bit too fast. Let's tweak it again. I'm pretty sure that if I go for like 100, it's going to be too slow. Yeah, that's a bit painful. Let's say 600. 600 is pretty nice. And let's try with the trigger. The trigger, I can do small correction, as you can see. And yeah, doesn't feel too bad. I'm not a designer, keep this in mind. We need to shoot now. So for this, we're going to add a weapon to our ship. And I'm going to define them in a new file called weapons.ini. I'm going to include it here. So weapons.ini, and as long as I'm here, I'm also going to create the one missing for the UI and for the audio. This way I don't have to do it later. Okay, weapon. What is a weapon? It's going to be a spawner. It's going to spawn something called a laser. It's going to do it one at a time, and it's going to do it every 0.2 seconds. We also don't want to wait for the first delay. We want to define a speed. It's going to be 1000, 0, and I want it relative to our current orientation. We also want to make sure that we're going to delete everything if we get deleted ourselves. What else we want here? I'm going to nudge it slightly on the z-axis so that it's under the ship instead of being at the same level. And I feel like we have everything here. So laser is an object, it has a graphic. And this one, we don't have a texture for it, so we're going to use an internal texture called pixel. It's a 1x1 white texture. And because 1x1 is a bit small, we're going to resize it to 20x5. We're going to say that the pivot is on the left side of it. We're going to say that the color is red for laser, and we want them to only stay there for 2 seconds. And if I didn't forget anything, we should have like shooting laser, except that we don't want them to shoot all the time. So here, when we create our weapon, we're going to say on create object enable ourselves false. And now, good. We need to do some code, and we're almost done with the coding we do today. So shoot, we're going to say if I find a weapon among my children that inherits from the section weapon, we're going to say weapon enable. We're only going to enable it if our input shoot is active. And now if I press S, I shoot, though I cannot button mash. So let's change this. We're going to say here, auto reset equal delay. This way the delay is going to be reset every time we turn it off. And now I should be able to button mash, and it also should work with the right trigger. Excellent. What if we were playing with friends? It's always more fun with friends, right? So let's keep this here. The basic version is actually pretty easy to do. We're just going to go to our main here, and instead of spawning a ship, we're going to spawn ships. Here we're going to define what it means to be an object called ship, and here we're going to say we're just going to have 2 children, one called ship 1 and the other one called ship 2, and we're going to define those guys. So ship 1 inherits from ship, and we're going to put everything that's specific to ship 1 in it. So like the keyboard inputs, texture, color position, there we go. And for the ship 2, we're going to change the texture, we're going to do the H1, we're going to change the color, spawn on the other side, we're going to face the existing one, 180 degrees. We're going to say that this one is only going to use the second joystick, which means that here we're going to use the first joystick, gamepad, sorry. 25 years ago, it was more joystick. Here we're going to use key up, left, down, and right for our default bindings. I like things well aligned. There we go. And if I were to restart our scene, we can see we have 2 ships that can be controlled independently, just like this. How about we do something a bit more advanced? I said that the data, once it's in memory, it's a live repository. We can change things on the spot as much as we want. So let's do something a bit advanced. It's going to be a bit harder to follow, but let's say, for example, I want to configure our ship with like additional property. Like, for example, I want to control the laser color on the ship directly. Let's say that this guy, I want it to be yellow, and this one here, I want it to be green. So one way to do it would be to create like additional weapons. So like, for example, I would have like a ship 1 weapon that inherits from a weapon, and here it's going to have a laser color that inherits from ship 1. But I don't want to do that manually for all the ship. Maybe I will have hundreds of ship, or maybe I will create ship on the fly and it won't be possible. So let's do this dynamically. So here, instead of hard coding our weapon, we're going to say set that new section, the laser color to inherit from ourselves. And here we're going to say config set parent of that new section to be weapon. So it's basically doing exactly what we put it here, except it's doing it dynamically. We popped 3 times the current section, so we need to push it 3 times first. If I didn't mess up, we should have, oh yeah, I didn't mess up because I didn't do everything. That's only part of it. We need to say in the weapon here, when we spawn our laser, we're going to retrieve our laser color, and we're going to set the color on the spawning of that laser color. Now, hopefully, we are spawning yellow and green, and this is dynamic value. So if I were to say set ship 1 laser color cyan, Now we are shooting cyan laser. It works for any properties, obviously. This is just a demonstration on the laser color. How about having some game modes? So we're going to go to main. We're going to define one game mode called 1P for one player and 2P for two player. And here we can have like any kind of properties, again, like for example, different configuration for asteroids or score rules or things like this. But here we're simply going to say we want different list of ships. So in one player, we want ship 1. In two player, we want ship 1 and ship 2, which means that in our ship here, I'm not sure why. Yeah, there we go. Instead of hard coding it, we're going to, well, first, we're going to say in the main, we inherit from the 2P section by default. And here we're going to get the ships from the main. So by doing this, we have two players. But if I were to change the parent of the main, and I put it on one player, if I were to restart now, we are in one player mode. So obviously the best way would be to put it in a menu. I don't have a menu, so I'm going to do the next best thing, which is to put it as an input. Sorry. So I'm going to say key 1 is going to be one player, key 2 is going to be two player. And here I'm going to handle them. Input, one player. I'm going to say the same thing I was doing in the console. So setting the parent of main one player, and I'm going to delete ourselves so that we can restart the entire scene. And here, same thing for two player. And if I didn't mess up, by pressing 1, we go to one player. Pressing 2, we go to two player. Okay. I don't know why I quit. I shouldn't have, but it's okay. We are going to add a bit more fluff to our game. So we're going to add like an animated background. We're going to add the game music and a small HUD. Let's start with the background, actually. Restart this. There we go. The background, it has a graphic. We are going to use the internal pixel texture because we're going to animate it with a shader. We're going to say it has a parent camera. It's going to be the main camera. This way we can say scale to cover the entirety of the camera and go all the way to the back of the camera. And finally, we're going to use a shader called star shader that we have in the shader.ini. See, it's only a few lines of code, but I'm definitely not skilled enough to do live coding of shaders. So this one was prepared ahead of time. And now if I didn't mess up, by just restarting, we have our background, we are little shader to do some stars. Let's get some gameplay now. We're going to add a HUD. Our HUD is going to have a size that's going to be the same as the main camera, and we're going to add an element to it, which is going to be our score. Our score is going to be a text object, so we need to define what it means. Being a text object means that you have a graphic, that you have a text component and not a texture this time, and we're going to give it a font called game font. Now we're going to do the game font here. We need a typeface. Let's find a typeface for our font. There we go. And we're going to say the character size is going to be 60 points. Okay, so here by default, we're going to display 0. We're going to say our position. We want to align the top of our cell to the top of the HUD with a little offset. What else do we want here? Well, let's start with this. There we go. We have our little score at the top. We're going to say that it's unique so that we can easily interact with it. And we're also going to give it, well, we're going to do that later. Let's interact with it. Again, we could do this in code, but it's a very small interaction, so I'm going to do it here. It's a bit like Blueprint versus C++, right? So yeah, I'm going to say we have a trigger. We're going to call it score trigger. Let's put it in a separate section this time. Score trigger, we're going to define a new event. We're going to call it update score. And here we're going to push the first parameter. That's going to be the value we want to increase. We're going to retrieve our current value. We're going to add them together. And then we're going to say to set it back on ourselves. And we're also going to add an FX on ourselves. Yeah, I can do it. And we're going to call it add score. An FX is a way to modify properties of an object following some curves. Here I want a single curve, so a single slot is going to affect our scale. The curve is going to be a sine. We're going to say that the end value is going to be 20% more. It's going to be a little pulse. And then we're going to say and time is going to take 0.2 seconds. Okay. We need to, well, we're going to score, but we don't even have like collisions and things like this. I'm like going ahead of myself. Let's add an object class, right? We didn't have objects yet. On the object, we're going to define a physics body, and this physics body is going to be dynamic. We're going to see it made with a single part. This way, we can just approximate it like with a circle. This part, we don't want it to be solid. We don't want them to bounce off each other, and it's going to be a sphere, so in 2D it's a circle. And if I didn't mess up here, if I say set physics show debug true, we can see we have a physics body for everything except our ship. That means that our ship is not inheriting from object. And here, if we do this, now we have physics object. Let's tweak them a bit. So in the asteroids, we're going to define a radius for our sphere. We're going to put 20. And let's see. Hey, 20 is pretty good. We keep it. We're going to define a collision flag. We're going to name this one asteroids, and we're going to say you are colliding with laser and ship. And because I use literals here, the engine will automatically assign power of 2 values here when it encounter a new literal. So I don't have to worry about the actual numerical values. Here we're going to modify our ship. We're going to say radius 15, a bit too big this time, 12 is good. And this is a ship, and ship only collide with asteroids. And finally, we need the lasers. And laser is going to be a laser and collide with asteroid. Okay, so we have collision, but we don't do anything with them. Again, we could do this in code, but it's going to be very simple. It's the same thing. So let's go back to our object. We're going to say we have a trigger. It's going to be called object trigger. We're going to define, let me scroll a bit, object trigger here, and we're going to handle the collide event. And we're just going to say delete the object when they collide. And you can see now when they are colliding, they are being deleted. We're going to extend this for asteroids so that we can get some score. So here we're going to say trigger list. We're going to extend it with an asteroid trigger. We're going to define the asteroid trigger. And here, when we collide, but only with a laser, we want to fetch our value. So we're going to have to add value to our asteroids. We're going to fetch our score. And we're going to fire a trigger on the score. We called it update score, and we're going to pass parameter the value. So here we're going to define value of 100 for the small asteroid and 200 for the big asteroids. And if I were to do this, you can see we are scoring now. So let's add some iScore. To do this, we're also going to leverage the config. We're going to modify value at runtime. We're going to call it iScore, and we're going to put it in a config section called save. So here, iScore, we start with 0. In the UI.ini here, we're going to handle it. We're going to say fetch save iScore. We're going to get the max of the new score and the old iScore, and we're going to put back iScore with a new value. And we need to push a second time the new score. And if I didn't mess up this here, if I say get save iScore, we can see we have 800. And if we reset, the iScore is still here. How about we display it? So we're going to add the child to our score. We're going to call it iScore, and we're going to define it here. iScore is a text. By default, we display 0, and it's going to have a color called lime. And also we're going to say our position. We want to align the top of ourself to the bottom of the score with a little offset on Y. And let's see if it's here. Okay. Oh, and by the way, because it's a child, we see that it pulses as well when we score. We don't want this, so we're going to say ignore from parent. We're going to ignore the scale and the scale component of the position. And now only the parent is pulsing, not the iScore. And we're going to be very brutal here to update its value. We're going to use a track that's looping. And then every single frame, we're going to fetch the value of iScore. score, and we're going to set it on our cell. And now the I-score is displayed, and if I were to make a better I-score, it's updated. Except that if we leave and come back, I-score is being reset. Let's make it persistent. So for this, we're going to go to main. We're going to add like a save file, and here instead of hard coding it, we're going to ask Orcs what is the best place to save that file, right? It's going to be different on Windows, Mac, Linux, iOS, Android, HTML. So to do this, we're just going to call file get application save directory, and inside this we want to create a sub folder called asteroids and a file called ascore.save. And we're going to use this in our scene. So when we create a scene, we're going to fetch that save file. And then we're going to say load it. We're going to use the config to serialize it. We could do it in binary and things like this, but again, we only have a single value. So pretty easy to do it this way. Here we're going to say retrieve the main save file, and we're going to say config set origin of the save section to that file name. So basically we are binding the save section to that file so that when we're going to save it, only the save section is going to go into that file and not the entirety of our config, which would be quite a lot. So now if we set a new I-score, we have 600. And if I leave and come back, hopefully we still have 600, and we can check it on disk. I think I have it here. See, we went into app data roaming, created the asteroids subfolder. And if we look at the content of this file, we can see it's just basically some config, which means that it could be very, very easy to cheat. So to prevent this, we're just going to say save it with encryption. And now, if I were to go back and check this file, you can see it's much harder to cheat. It's not impossible. Obviously, you can reverse engineer the process, but it's much more involved than just adding a 0. Okay. We have persistence. What else do we need? We need some music, we need some sounds, and we need a game over. Let's work on this. Let's keep this here. First thing first, let's do the music. So we have an audio file. We need to define what the music is. Music as a sound component, it only has one of them. It's going to loop. And because I think the music is pretty loud, we're going to put it at 0.3. And then we're going to create our game music, inheriting from music. And here I'm going to use an Amiga file format. So the Amiga, for those who don't know, are a bit too young. It's a computer from the 80s. And they were using real-time synthesis to store audio. And that has one of the benefits of it is that if you look at the data here, you see that the files are tiny. Like this one is 15 kilobytes, and this one is 40 kilobytes. So we're going to use this here. So PGM mod, and we're going to create one for the game over music, which is going to be this guy. Okay, and by restarting, we have music. It's quite loud. It's even louder than it. Remember? Yeah, you know that. There we go. Okay. So we have a game music. We also want to have a single music at a time. So we're going to just make sure we don't have music playing. So when we create a music, we're going to retrieve the current music, we're going to delete it, and we're going to set ourselves as a new music. There we go. Which means that here, if I were to object create the game over music, it replaces the game music, and similarly creating the game music replaces the game over music. Okay. Because it's a bit annoying, we're going to say sound set bus volume. Oh yeah, here we can modify the bus we want. Like for example, if I were to change the pitch on the master bus by 0.5, we have the sound distorted. But change the volume of the master, we're going to put it to 0 so that we can continue quietly for now. Okay, we need to define what a sound is. A sound as a sound list. This time we're going to say the lifetime is going to be sound. So as soon as the sound component is done, the object is going to be recycled. What else we want here? They're probably also pretty loud, so we're going to put a volume. We're going to also add, like a random pitch so that there will be a bit of variation on the pitch of any sound. And here we're going to define a laser sound inherit from sound. And here we need the sample, which is in SFX. We're going to use the first one. And we're going to create one for explosions. Yeah, we need explosions as well. Okay. Okay, if I were to restart, oh, first we need to hook them, right? So weapon, the laser comes, oops, child, come with a laser sound. And because we muted it, let's unmute this, and we can hear we have laser with different pitch. We need some explosions. Let's work on this. You know what? I'm going to change a bit this here. I'm going to say bus. Let's call it BGM. And here we're going to say sound set bus volume of BGM 0. So we don't have the music, but we still have the SFX. Excellent. What was I doing? Oh yeah, explosions. Sorry. Explosion. We're going to use an animation this time. So we need to define animation set. It's going to be ourself. Our start anim is going to be called explode. Orcs use an animation graph, but here we only have a single animation. So when explode is over, we do nothing. And we're going to say, once we're done playing animation, you can go away. What else we want here? We want the sound. So we're going to say explosion sound, except that this time I'm not going to use childless. If I were to use childless, if we delete our object too soon, the sound would go away. So we're going to say on create object create explosion sound. Okay, for animation, we need like key duration. We're going to say 50 minutes gone by default, and we need a texture. We need to tell it where the animation is stored. So here, if we go to texture, explosion, we have one, it's a 2x2 regular grid, it's called stars. So explosions, stars PNG, and because we use a grid, we can leverage this and say it's a 2x2. Okay, now we need to create it. So once we get destroyed, we're going to transfer our position, the scale, but also our color, because otherwise it's going to be white. It's not very pretty. So we're going to fetch our color, get color of ourselves. We're going to create that explosion, and we're going to say object set color. We're going to transmit it. We're also going to say object set parent of the newly created ourselves, so that we transmit all our position, rotation, and scale. And finally, we're going to detach it so that when we get deleted, it will remain where it is. Up. And let's see, we have the sound, but we don't have the visual. So I mean that I messed up. Was bound to happen. Okay, can't evaluate command, stack is empty. I forgot to push something on the stack. And here. Okay. Let's try this again. Yeah, we have our explosion. Easy fix. We need a game over. And I'm pretty sure that's the last thing we need here. So game over is a text. The text, it has a text, a string that's going to be game over. Okay, what else we want? Parent camera is going to be the main camera, because we want to be able to scale for 80% horizontally, so 0.80. What else we want here? We want an FX. We're going to animate it a bit. Single slot FX. We're going to set it in absolute value, and we're going to say that it's going to loop. The type is going to be an HSV space, and then we're going to say the start value in HSV is going to be 011, and the end value is going to be 111. And finally, we're going to say the end time is 5 seconds, so it's cycle after 5 seconds. We also want on create, we're going to fetch the scene, and we're going to say object set owner of ourself, the scene. What else we want here? We want the music. Game over music. Okay, and we want to create it. So in the ship.ini here, we're going to extend our trigger list. We're going to add a ship trigger. In the ship trigger, we're going to say, well, when we collide, we're going to create a game over. Okay, let's see if I didn't mess this one up. So when we collide, we have a game over. It's pretty ugly, so let's fix this. We're going to say the font is going to be a new font called big font. Big font inherits from game font. We're going to just change the character size. We're going to put it to 300. And now, if I didn't mess up, that's prettier. We don't know if we have the music because I muted it. So, BGM. Let's see. It's working. We want to pause the game. And for this, we're going to use global inputs because that's the easiest way to do it. We're just going to say input set value. We're going to call it pause. And upon deletion, we're going to say input set value pause 1. And we're going also to say our game over is not going to be paused. We still want the animation on it. So it cannot be paused. And similarly, we don't want the music to be paused, nor the scene to be paused. Okay, and here we need to handle it in code. That's going to be our last code edit. In asteroid here, we're going to say if aux input has been activated of our pause input, we're going to say pause game, the not is game pause. So it's a toggle. Okay, if I didn't mess this one up, we are pausing the game, we still have the music, and we should be able to restart pretty easily. Okay, I think we have most of our gameplay, right? We have explosion, laser, sounds. Let's export it. To export it, all we have to do is build a bundle. Actually, it's a release build. It just adds some parameters to Visual Studio so that when I run it, it's going to generate the bundle. So let's zoom a bit. All it does right now is discover all the resources that we've been using, only the one that we've been using. It's going to compress them, encrypt them, and pack them inside the asteroids.obr, and it took 0.2 seconds to do so. We can create as many bundles as we want. It's easy to filter what we want to go into a bundle. We can even bundle everything inside the executable. Obviously, you don't do that if you have like gigs of data, but it's very easy to do. It's just a change on the parameter, command line parameter. And here we can see that they also bundled our iScore, which is probably something that we don't want. So let's remove this little guy here. And we're going to say in exclude list, we're going to retrieve get main save file. And now if I were to run it again, we can say that it's been skipped. There's a rule skipping the iScore. Okay, let's look at what we have here. If we look at the bin, we're going to take the executable, the bundle, and the engine. We're going to create a shipping folder. And we see that our asteroid is about 240 kilobytes, data is 97 kilobytes, and the engine with all the dependencies is about 2.8 megabytes. By running this, we have our game that we can easily ship, and we're going to ship it for the web. So we're going to go to Windows, gmake, we're going to go mscripten, make that shake, config, release web. This is going to take another 15 seconds. It's going to leverage the bundle, as you can see here. And it's going to end up in the web subfolder. And should take another few seconds there. We're done. Here you can see that the WebAssembly for both the game and the engine is about 2.4 megabytes. We have a bit of glue code for the JavaScript, the data. And if I were to run a web server locally and open Firefox, I should be able to go to localhost, have our game, and we can play it locally, multiplayer. And if I were to restart Firefox, you will see that our iScore should still be there. It's been, because we ask orcs where to save it, here it used the IndexedDB to save the local data. I'm going to delete it. Okay. Let's see what kind of effort we put together, right? So we're going to use cloc -- no recurse. We're going to go into our folder. We call it asteroids. Let's copy this. We're going to look at the data config. We're going to look at the source, and we're going to look at include. And not to skew the result, I'm going to remove the template in data. So config, I'm going to remove the template file. They are quite big. And let's run this. We can see that our effort today to make that little game was about 300 lines of config and about 150 lines of code together. And we can like easily, add like new players on the fly or modify it in data. I would like to take another like 5-7 minutes. I'm sorry, I'm going to go a bit over time. Feel free to leave. It will be recorded anyway. And after that, I will take any question if there's any. I just want to showcase a couple of things that I think are important for data-driven development. One of them is usually when I do my include here, I add like a dev.ini file that I do not put on source control. It's only something I create locally, and I keep it locally, and that's where I add some cheats. So here, for example, if I were to say I'm going to modify the background, I'm going to bind it to a clock, I'm going to call it test. I could do the same thing for, I don't know, for music, for example. Music, I'm going to say clock test, and here I'm going to define the clock. We're going to say it has some modifier list, and it's going to multiply it by 0.1. And by running this version here, so we can read it from Visual Studio, right? You can, well, maybe 10 was a bit too much, but you can see that the background is definitely going to go much slower, and the pitch of the audio is also very, very slow. So let's try with 0.9. Let's restart it. You can see that the audio is a bit slower, and we can modify this on the fly. Like if I were to say modifier for the clock, it's called test. I'm going to say multiply. This time is 1.2. So now it's going to go faster, and it affects both the music and the background. So it's very handy for like doing local only edits. And as a matter of fact, I released a game about 10 years ago with a friend called Little Cells. It was released on Mac, Windows, Linux, and Android. And it has a dev.ini. So the game by itself is like a very simple, casual game. We can see that we have like an option menu. There's nothing in the middle. There are 4 buttons to the right. If we look at the tutorial, it shows you how to grab a cell by using like a fake cursor visual. And if I were to look at the dev.ini here, you can see I already had some debug stuff. I actually had like some debug viewport where I like show different textures, internal textures only. But here, if I were to uncomment the Android inclusion, and if I were to run the game again, you can see the font factor is different. It's vertical. If we look at the option now, it has leaderboard, the Google Play, and the achievements. And if I look at the tutorials, now instead of being cursor grabbing the cell, it's a hand. So basically, the code base for the game is virtually identical for all the platforms, except for the specifics like the Google Play Store interaction or the Steam interaction. But the gameplay itself is 100% identical, which means that to test a different platform, all you have to do is load the data for that platform. You don't have to use an emulator. You don't have to wait for another build to be triggered. And this data is only overrides. It's only things that have been changed on the Android version versus the desktop one. It's not everything inside it. It's only the delta. And it's pretty easy by just commenting a line in and out to go between the two versions. And I think this is quite a powerful feature during development.